Okay, well, we're going to have a real treat here now. We're actually going to have Joe demonstrate the famous Patriot meter. And Joe, why don't you explain exactly what we're going to do with this little procedure?
Okay, actually what I have here, when I had these in production, this was the actual test fixture that I used for the coil. Just a little stand that I built. And after I would get done going through the calibration procedure with the computer that I had, there's actually a connection inside the meter housing that I connect my computer to, and that goes out to my programming fixture.
Okay.
And it programs all the code or firmware into the meter to tell it what to do and how to, interpret readings. And after that's done, I do a double check of every target that I made on little sticks like this that I wave past the coil, just to verify that the meter is in fact calibrated properly.
So you mean, Joe, on every single one of those meters that you produce, you actually went through and bench tested every type of different various target?
Exactly.
Wow.
At least once, and usually 2 or 3 times. Because when I actually do the programming using the calibration fixture, there is some variance. I can sit in, actually I use the plus and minus keys on the keyboard. And you have various settings like nickel, pull tab, screw cap, quarter. And as you get into each category, you use the plus and minus keys, and that basically moves the meter to where I want it to be. And then after that's all done, to verify its accuracy, I use real targets to make sure when I wave it past the coil, the meter does in fact read where it's supposed to read.
Well, that's true quality control right there. Well, why don't you, if you would you give us a demonstration of how you do perform that test?
Sure. I'm using an older Sovereign here, and it also has my Insight meter in it. So because I have the Insight installed, I have to use an external speaker for this demonstration. Otherwise, you wouldn't hear any audio.
Sure.
So basically, that's what this setup is. I come out of the metal detector, and there is a connector in the back of the meter it plugs into. And then we have another cable from the meter going up to the search coil.
Mm-hmm.
So let me turn the detector on and set the threshold. Okay, now the meter actually has a power on-off and a battery test. So if I turn the meter on, and it's picking up some electrical interference is what that is. Let's see, let's go off of auto. Give us a little more stability.
Okay.
I actually have a light built into this, so let's turn that on for the demonstration so you can see it a little better.
That's great.
That shows up perfect.
And if you want to test the battery, you can use the power switch. And basically, if you read up in the green area on the bottom of the scale here, you know you have a good battery. So that's a good reading. And the reason that bounces is because the lights are basically what do I want to say? Pulse width controlled to keep a constant brightness. And as the meter is internally adjusting to keep the brightness constant, the meter's picking up that little bit of fluctuation on the meter test. If I turn the lights off, you'll notice the meter's stable, it stays in one area. So we have good batteries, that's good. Do you want the light on for the demo?
And I had one question. That light, though, if somebody, a user, had that on, that would have no appreciable effect on the accuracy of the reading?
Not at all.
Okay.
Not at all.
Okay.
You only see that movement in the battery test. When you're actually using the detector, it does not affect accuracy at all.
Okay, great.
And also, there's a timed position on the light. A lot of the beach hunters and that, instead of having the light on constantly, which would decrease your battery life somewhat. There's only one 9-volt battery in here, but it does give pretty good life. But anyhow, instead of keeping it on constantly, a lot of guys like the fact that they can turn it on only when they hear a target, like that, and then after so many seconds it turns itself off. So if you forget to turn it off as you're detecting, it'll turn off automatically. So let's turn that back off again. Okay, so the first thing you want to do is you want to calibrate the meter to your coil and to your detector. And this has a very unique circuit that we designed that I call auto coil, which stands for auto calibration of input level. And it will automatically calibrate the box, the meter, and the coil for perfectly accurate readings. And the way that works is if I press the autocoil button, the meter is going to start scanning. It's going to go into a scan process, back and forth, back and forth. And what it's doing is looking for a quarter signal, a 180 or a quarter signal. Once it finds that, it enters into the calibration mode where it calibrates the needle to the actual graphic icons so that you have 100% accuracy.
Okay, well, Joe, what if you have a target that is a different size than a quarter? Say you have a penny or a dime. Well, how would the meter react?
You mean for the calibration?
For the calibration.
Actually, there's a certain range that's programmed into it. So, if I remember right, I think it's any target between like 175 and 180 will still make it calibrate accurately. But just to be safe, I always recommend use a quarter. And I know if you use a quarter, the calibration will be 100% accurate.
Oh, okay. Well, I don't want to, stop you from continuing your demonstration. So after then, you would calibrate using the quarter. Then what would you do?
Okay. So what you do is you initiate what's called the autocoil programming sequence by pushing the autocoil button.
Okay.
And when I do that, the meter is going to start sweeping back and forth. Now it'll do that a number of times. If it doesn't see a quarter reading across the coil, it'll eventually time out and it'll keep the original calibration setting that's in there from the last time you calibrated.
Okay.
But if it sees a quarter reading, it'll accept that as the new calibration.
I see.
And then it'll calibrate according to the new...
And how long would you, how often would you have to recalibrate that meter with the detector?
Honestly, if you keep the same coil, the same control box, and the same meter, you may never have to do it again.
Oh,
it's that good. Because once you do it, it's locked into memory, it's written into memory, and it stays there.
So even if someone were to disassemble that metal detector and put it in a travel case,
yep,
they could reassemble that and it would still have that same accurate...
Absolutely.
Okay, that's terrific.
Yep.
Okay, well, that's quite a product. What else then would we do after we have that calibration?
Okay, so what we're going to do, like I said, you start the sequence, and it's going back and forth. I'll let it do it a few times here before I run the quarter over the coil. And it's looking for this quarter reading. Now the next time it goes back to 0, it's going to initiate the calibration process. Now it's calibrating. And it'll stop exactly at 180. And it's calibrated now.
Okay.
Alright, so that was a quarter. Now, to show you the accuracy, once it's calibrated, here's a nickel. Okay?
Alright.
Wow.
Oh, dead center. And what's key is nickel reading for years on meters, different machines through the years, is that's the range where you would have, say, some fine gold bands, finer jewelry, smaller gold items. And a lot of times when you set the discrimination on these machines, it's hard to tell between the nickel, which would represent, say, the nickel in the jewelry, and the pull tab.
Well, here's an interesting thing now that you brought that up. A lot of times the beaver tail, the small teardrop off a pull tab, will read the same range as a nickel.
Okay.
Okay. Now, if I were to go across one of those right now, because I am operating in the block mode, I have two different modes on here. I'm in the block mode. It would make the teardrop and the nickel read exactly the same. They would both read right in the middle of the nickel scale.
Okay.
But when we actually did the programming on here, we set up a linear mode that reads a whole bunch of finite resolution points. And if we go to the linear mode, there are now 17 little discrimination points in this whole nickel range now. So you could actually see the subtle difference between a beaver tail, a nickel, a buffalo nickel, a V nickel. They all have different conductivities. And so in the linear mode, you get finer resolution of those targets. It doesn't block them or lump them all into one category.
Wow.
The only drawback to the linear mode is you do get a little more target variation because it's very sensitive at that point to any electrical interference. But in those cases where you're trying to differentiate between maybe a gold ring, a pull tab, a teardrop, a nickel, that gives you a little better resolution to do that.
Would you recommend, though, that somebody would search, and if they got a reading in the nickel pull tab area where you talk about that tear-shaped piece, that then you would hit the linear button?
You could
switch?
do that. You could do that, yeah. Typically, I always hunt in the block mode, but yeah, that certainly would work if you wanted to do that. And just to show you how that works, let's take a screw cap, an ordinary screw cap, okay? Now, if I go in the block mode, you see where screw cap's at? Okay?
Yes.
Now, if I flip this over, okay?
Okay.
You see the little difference in the reading?
Yes.
See, I'm actually picking up a little bit of noise in here. Inside the house is really difficult because you pick up noise from your routers and from your dimmers and fluorescent lighting, so you get that little needle bounce.
Plus, you would have the electric going through the wires, electrical wiring in the house.
But once you get outdoors with it, you get the coil on the ground. It's very, very extremely stable. But getting back to targets, okay. Let me make sure I'm in the block mode here. Okay, here's a regular standard pull tab.
Yes.
See, we're getting some of that's from the battery. No, there's something interfering with it in here. What am I picking up?
Oh, my pacemaker.
That's better. Okay, here's a standard pull tab.
That's right on the money.
Yeah.
Okay.
That's right.
Here's a square tab.
Wow.
Hey.
Okay.
That's unbelievable.
Here's a nail.
Right.
And it'll be all the way down on the red.
Yes.
Right away, and the red light comes on too.
Yeah.
Yeah. Wow.
So as you can see, it's very quick responding, very accurate.
One question. You mentioned the linear mode. In particular, you mentioned on the nickel, there's 17 different degrees of, I guess, conductivity of the target that the meter would be able to tell us.
Yeah, what you have to think of is, it's been so many years since I've worked on this design. It's been about 10 years. I'm trying to remember. There are from 0 to 180 max scale, from minimum to max scale, I believe there's 255 points of resolution. Okay? When you're in the linear mode, it is capable of displaying each one of those 255 points of resolution, depending on the target conductivity.
Now, would you recommend that, say, if someone had a Patriot meter, that they, just in that various, like say the one like we mentioned, nickel, the 17 variations of signal, that you mentioned you could tell the conductivity difference between say a Buffalo nickel and a Flying V?
A lot of times you can.
Okay.
Yep.
But would they have to bench test that to note those linear differences?
Yeah. You'd kind of have to see where those tend to fall, whether they're at the high end of the nickel range or the low end of the nickel range. Yes, that's correct.
Oh, okay.
Now, if you were in the block mode, they would all read dead center nickel range.
Okay. Now, would it also make a difference on what our reading would be on that meter if, and we've talked for years, I know me and Bill, that the angle of the target.
Yeah.
Now, that would have, I would think that would have an impact.
It would.
Well, let's just say you had a nickel that was, say, like halfway, like it was kind of on its side where you can maybe pick up maybe half of the surface of the nickel. How would the meter react on that target?
I mean, all of those factors can affect it. It's hard to simulate that. Let's see if we can. I don't really know if we can simulate that indoors, but here's a nickel. Do you want it in the linear or block mode you're talking about?
I think mode? Either way. I mean,
either way.
We could, I think,
okay,
yeah,
let's go on edge, okay? This would be on edge.
Okay.
We're on iron right now.
Okay. It took us up. Look.
Mm-hmm.
Yeah, that's great.
Now here's flat.
Right in the center. Okay, why don't you try that where it have maybe half the side. Dead center.
It all depends, on how you hit the target. So angle is going to make some difference.
But it's like with the, when you're out metal detecting, you could have a bad target next to a good one, and sometimes you're catching a piece of that signal where you're going to want to step to the side and sweep the coil at a different angle.
That's exactly right.
Okay.
Yeah.
That's great. What else would you like to demonstrate in regard to the meter, Patriot meter for us?
Just, the main thing is just the accuracy. It is extremely accurate on known targets. Coins, pull tabs, screw caps, iron. A lot of times, you know, these iron bottle caps can be a real problem for a lot of detectors.
Oh yeah.
You go over these, especially if they're rusted, you can get readings all over the place. High readings that sound like a coin, low readings that sound like iron. So what I developed to kind of help identify this type of target is what I call the iron sentry, which is this light here and the circuitry for that. And I can tell you from experience, both from indoors, like when we did the actual testing and everything, and field work, actually using it in the field, that it is very accurate. If that light comes on, you know that you're going over iron. I don't care if it's a teeny little small piece of iron or something large, and you can kind of tell by watching the light whether it's small or large. If the light comes on quickly and just stays on, it's a larger piece of iron. If it flickers, it's either like a bottle cap or something small or a couple small pieces of iron.
Okay, you had mentioned sometimes, you know, a signal like with a bottle cap, I guess on detectors, it could be all over the place. What about, say, you had a bottle cap or an iron object that was about the size of a bottle cap that had been in the ground quite a bit, and you have the halo effect?
Yeah, that'll pick it up right away.
And
because what you're going to get, if you have the iron sentry on, as soon as this encounters any type of iron, the programming inside the meter knows that it's iron. Okay, and the light's going to immediately come on.
Yeah.
So,
or it's going to flicker. If you see it flickering even, you know there's iron in the hole.
so even if you had an iron item that the iron was starting to oxidize the soil around it,
Yep.
it would still ring out as iron on
Now,
the meter.
Exactly. The audio, if you listen to the audio, you're getting some high signals. You're getting some high pitches in there. And, you know, at times you think, oh, is that something good? Or, you know, it sounds
Exactly.
good. But if you see that light come on, even for an instant, you know it's that good. You know that there's iron in the hole.
Now, I know that these are designed for the MINELAB sovereigns.
Wow.
How quick is the target recovery rate, and would the meter? I'm sure would the meter recover as quickly as the actual metal detector on? Like, so you go over good target, bad target.
Exactly. It follows the meter or the output of the sovereign. So as fast as the sovereign is, the meter's tracking right with it.
Okay, and on the sovereign, that's pretty quick recovery rate. You hit bad target, good target.
Mm-hmm.
Okay.
Whatever you hear in the audio, it's tracking that audio very, very, you know, quickly. It's basically in sync with it.
Okay, yeah, it's that's in fact part of the not only calibration of the actual target, but the fact that the machine is accurate right with the meter.
Mm-hmm.
Okay.
And I was showing Bill before. For example, you wouldn't want to do this, but let's say instead of using a quarter to calibrate it, let's say you used a screw cap. Okay, just to show you that it does in fact, it's not a gimmick. It does in fact look at the target.
Okay.
And it does calibrate the meter to 180 on the target. Okay.
All right.
So let's say we use this on the autocoil. Now, you will see when it's done calibrating, this is now going to read like a quarter. So now it's going to go into the calibration, and when it's done, it's going to read 180. Okay?
Okay.
So that's going to read 180. So is a quarter going to read 180. So you'd be digging screw caps all day long thinking there's quarters.
Wow.
Okay? Now, if you do the calibration correctly using a quarter, then it'll correctly categorize the screw cap. Yeah. It picked up another signal. Hang on a minute. If it picks up any electrical interference while you're doing the calibration, it tries to calibrate to that signal.
Well, you wouldn't have that problem outside, I would
No.
assume. Unless you buy some power lines.
So I guess if you had your hunting buddy had the same setup as you, that
You'd
you
have
could,
a problem.
you'd
You'd
go,
have to get a couple of feet apart, yeah.
well then, but also that say behind his back, you could recalibrate his machine with the screw cap and slow him down.
Oh, that would be great, huh? So anyhow, yeah, let's set
Be a
this
good buddy.
back to another reading.
Yeah, real good buddy.
Here's a quarter, okay?
Right.
Right on a quarter. Now here's a screw cap. Whoops. Is that reading screw cap? Yeah, it is.
Yeah, it's reading screw cap, yep.
So with it calibrated correctly, it does identify correctly.
Oh, that's fantastic.
Yeah.
Joe.
So I mean that's pretty much it. You know, without getting into all the nuts and bolts.
Sure. Bolts and bolts, huh?
Yeah.
Wow.
We just need to know how it operates.
That's right. That's exactly right.
I mean, if you have any other questions or anything, but that's a quick demo.
Well, I have to tell you, I'm impressed with the different levels in each of the discrimination category boxes you have there.
And that brings up something else. Every category is not the same. Like on nickels, I have 17 finite points of resolution because I'm trying to separate beaver tails from this nickel from a gold ring. When you get up into maybe some of these other categories, I might only have 4 or 5 resolution points.
Here's a question. What if you have, I know I've experienced this on different metal detectors over the years. What if you have like a big piece of aluminum and like say for instance, I'm not going to name the manufacturer, but say it reads out like an 81.
Okay.
Okay. How would the Patriot meter handle that?
More than likely, it would read full-scale coin. But you know what?
Because of the size of it.
All detectors are going to do that.
Yeah. Oh, I know they do.
Yeah, they all do.
So, I mean, that's just something that you can't overcome certain target conductivity.
Yeah, I think what you end up with like aluminum can that somebody ran over the lawnmower, you got those big shards of aluminum. And that's just a problem.
And it's a typical problem across the board.
Exactly.
Yeah.
Well, Joe, I want to thank you for giving us a demonstration of this meter. It's just really an incredible piece of equipment.
I'm surprised how accurate it is.
Yeah, I am too.
Well, thanks. You guys got the scoop. It's the first time I know that it's ever been shown on video.
Yeah, that's right.
Well, I did my best to
I didn't know you had
getting up close on it.
I didn't know you had the two modes, that block and that linear. I'll tell you something. I'm really impressed with that.
You would metal detect and block, and if you really wanted to get particular on the nickel and then do linear.
That's what I like. I've never seen anything like that.
There's a lot of features on here that I didn't go into.
No,
just like the meter itself. If you look at the meter.
Could you fabricate something like that for the X5 series, X3 series?
Not quite as easily. It could be done, but not nearly. If you look across the meter, you notice it's curved?
Yeah.
Yes.
Well, it's probably the only ID meter in metal detecting history that's had that type.
So you don't have reflection?
And the reason I selected that meter from the vendor is due to that fact. It eliminates glare and reflection.
Yeah.
It's just like when you go to a dentist and he's got the light and it's got the curved mirror.
Yeah.
It's so that it doesn't hit your eyes and, what's the same concept. So that was another thing I looked into. I wanted a meter that was no glare, low reflective, And the same thing with this, okay? There's an LED back here, a red LED. Right. But if you know anything about LEDs, they have a very narrow, view, like the angle that you can actually see the LED. If you're off axis and you look at it from the side, you really don't see it being very bright.
Yeah,
it's difficult to see. So by adding the Fresnel lens, it takes that LED light and it disperses it over a larger area and makes it so much easier to see, even if you're off axis and looking at it from the side.
Yeah. So now with your 9-volt battery, how long does that last?
I'd have to pull the specs, but the battery life, if you're not using the backlight constantly, it's phenomenal. It's like 1,000 hours on
a
battery. It's like unbelievable.
Wow.
I get on my when I did the X2 or the X5, I would get 25 plus hours or more on a 9-volt battery.
Now this is incredible. The guy that designed this, his specialty was designing water meters that lasted 20 years on a battery.
Gee.
Very microamps of current, very low current, very long battery life.
Wow.
Yeah, so it's got extreme battery life. One of the other nice little features that I liked about it, and this goes back to my transistor radio days, is when you want to remove the battery.
Oh, yes.
Yeah. You remember?
Yes.
Remember the transistors had that?
Yep.
Instead of having to get down here and dig at the battery, I said, no, we're going to do this.
Oh, that's great.
So
I tried to think of everything to make it, a good product.
That certainly is a great product. And actually people are paying more money for it today than what they were originally.
They are.